Okay, 2 more videos left to do. So this one's going to be about calculating with significant digits. So I'm going to cover addition, subtraction, multiplication, and dividing with significant digits. And I've got 8 examples, so this is going to be quite the length of time for this video. So we'll see how it goes. So the first one, 6.201 plus 7.4 plus 0.68 plus 12.0. Okay, I want to line these up and down like you're in elementary school. So let me start writing them over here. So we have 6.201 and 7.4, 0.68, and 12.0. Okay, notice I've lined them up on the decimal point. Okay, and we have, this one has 3 decimals, this one has 1, this one has 2, and this one has 1 decimal place. And what I want to do is I want to draw a line behind the ones that have the fewest amount of decimals. So that would be 7.4 or 12.0. Not the fewest amount of significant digits, but the fewest amount of decimal places. So they only have 1 decimal place. So I'm going to draw a line behind that decimal place. Everything behind that line is what we're going to round off. So we start adding up. We've got 1 here plus nothing. 0 plus 8 gives me 8. 2 plus 4 plus 6 is 12. Carry the 1. I've got 13, 14, 16. Put the decimal place, carry the 1, and 2. 1 plus 1 is 2. Okay. So now I want to look at where I drew that line. Now, remember this line is which ones have the least amount of decimals, 7.4, 12.0. Draw the line behind those numbers. Everything behind it gets rounded. So it rounds just like normal. So I look at the number behind, it's an 8. So that is 5 or higher. So this 2 will round up to 3. So my final answer is 26.3. And that's it. I'm done. That's my whole problem. Let's try another one. So this one will be shorter and simpler. So I have 78.62 plus 1200. Okay, so let me line them up. 78.62. And then 1200, it doesn't have a decimal, so that means the decimal is going to come in the rear. It's like a line, not a decimal, but I'm trying. You guys try right in the whiteboard, you see how far you get. It's not easy. Okay, so the decimal is going to be here. Okay, and the one with the fewest amount of decimal places is 1200 because it has no decimals at all. So we're going to line up right back there. Okay, so we're going to line it up behind. So we'll add from behind. We got 62 because it's not being added to anything. 8 plus 0 is 8. 7 plus 0 is 7. And 2 and 1. Okay, and we want to do the same thing. So we'll look at the number behind that line. Is the number behind that line 5 or greater? Yes, it is. So we get rid of this, and this 8 will become a 9. So the answer will be 1279. And you do not need a decimal place on it since it is all significant digits. The decimal place is not necessary. So 1279 is your final answer. Okay, let's try another one. 8.264 minus 7.8. Okay, this is subtraction, but I still want to line up the same way. So I write my 8.264. That was a better decimal place that time. 264. That is not a good 4 though. Better 4. And then minus 7.8. And I want to line it up with the decimals. So the decimal is right here in the middle. Okay, and draw my line. And so the one with the fewest amount of decimal places is 7.8. So I'm going to draw a line behind it. And subtract. 4 minus nothing is 4. 6 minus nothing is 6. Okay, and then I got to borrow. So I'm going to borrow right here, 7, 4. 12 minus 8 is 4. Okay, and then I have a decimal right here, and that would be the 0. 7 minus 7 is 0. Okay, so now I need to round. Just like if there's anything behind this line, I need to round it off. So I look behind my line, it's a 6, it's 5 or higher, so that will round up. If it was not 5 or higher, it would just stay 4, but it is 5 or higher. So it rounds up, so my answer is 0.5 is the final answer. Let's try another subtraction one. 10.4168 minus 6.0. Okay. Switch to my pencil. Okay, so 10.4168 minus 6.0. Draw that line. Okay. And now the fewest decimal places this time is with 6. It just has this one decimal place. So we're going to cut it off right here. Okay, so you're looking to see just decimal places. The numbers in front of the decimal don't matter. It's the how many numbers you have behind your decimal that matter. So this one only has 1 and this one has 4. We still subtract like normal, so go ahead and subtract like normal. 8 minus nothing is 8. 6 minus nothing is 6. And 1. 4 minus 0 is 4. And 10 minus 6 is 4. I'm going to make sure to write my decimal between these two 4s. Okay, so make sure to bring your decimal down just like in normal subtraction. Okay, what does this equal? Well, this number this time is less than 5. It's not greater than 5. So this just rounds off and it just stays 4.4. The rules for rounding are the same. Doesn't matter that you're calculating and taking in mind your significant digits. The math function is still the same. We just have to round it behind the fewest amount of behind the fewest amount of decimal places. So you look to see who has less decimal places, and that's who you need to put a line behind. The numbers in front do not matter, just the numbers behind. So how many numbers do they have behind that decimal? How many numbers do they have behind that decimal? So that's addition and subtraction. Now let's look at multiplication and division. So my first multiplication is 1.31 times 2.3. Okay. And you don't have to line this up the old-fashioned way. That's not necessary. Okay. You can just, you can just do it in your calculator, and then I'm going to tell you what to do. Okay. So if we multiply this out, what you want to look at when you're multiplying out is how many significant digits does each have. Okay. So this one right here, 1.31 has 3 significant digits. And right here, 2.3 has only 2 significant digits. So we use whatever number is less. So the number that is less is 2.3. It only has 2 significant digits. So whatever my answer is, why didn't I do it in red? I asked it to do it in red. There we go. Okay, now it's like double circled. That's better. Okay. So whichever one has less significant figures, that's what you're going to round your final number to. Okay. So the final number rounds to whichever one has least significant digits. So when I multiply 1.31 times 2.3, I get 3.013. Change my pencil in black. Okay, so the answer here is 3.013. Okay, but I only have 2 significant figures over here and 3 here. So I go to whichever one has least. And if I only have 2, then this answer can only have 2. Cannot have 3, cannot have 4. It has to match the lowest amount. So I start counting from the front. Here's my first significant digit. And here's my second significant digit. So I have 2 significant figures here. That's a bad arrow, but you get the idea. And then just like before, we want to round off what's behind. Okay, so we look at the number behind our last significant figure. It's a 1. That's less than 5, so it just goes away. So my final answer is 3.0. And that's the answer. That's it. It needs to be 2 significant figures because your smallest one has 2 significant figures. So your multiplication answer needs to match the same with only 2 significant digits. And make sure you round it off like you normally would with the rules of 5 or more, less than 5. Okay, let's try another one of multiplication before we go to division. 40.002 times 13.00005. I should have put like a little box here. So we're going to multiply those two together. And I'm definitely not going to do this one out. I'm just going to put it in my calculator. So I'll put in my calculator 40.002 times 13 point, it's got 5 zeros in there, right? Why did I put 6? I put 6, that's okay. 1, 2, 3, 4, 5, 6, and a 5. And that answer is 520.026002. 026002. Okay? So that's what the calculator tells me, but I need to go look at what these numbers are telling me. And this number right here is telling me it has 5 significant digits. The 40, the 0.0002. This one tells me I've got the 1, 2 here, plus 3, 4, 5, 6, 7, 8, 9 significant digits. Okay. And it's kind of obvious which one's going to have less significant digits when you look at the two numbers, right? So I know that 5's going to be, the top one's going to be less because it's obviously a smaller number than the first one. So that last one has a lot of decimal places there. So it's going to be that one has less significant digits. Okay. So if I look, I want 5 significant digits, so that means I need to go 5 here. So here's 1, okay, 2, 3, 4, and 5. So this is my 5th significant digit, so I'm going to cut it off right here, just to show you obviously. Then I look at the number behind it, so we're going to keep 5 digits. So 520 point, and now this 6 is greater than 5, so it's going to make that 2 a 3. So my final answer is 520.03. And this is my final answer. There's my final answer. Okay. So that's how multiplication works. Division's working the same way, but for the other operation, and it works differently, but the rules are still the same. So let's look at a division problem. So 0.00607 divided by 12. Let me change my color to black. Okay. So I have 0.0607 divided by 12. Now if I look at significant digits, I see that this one has, these don't count, okay? So those digits don't count. Remember, the zeros in front do not count, just the zeros at the end. So this one just has 3 significant digits, but this one obviously has less because it only has 2 significant digits. So let me put this in the calculator and divide it like normal. So in the calculator, this equals 0.00607 divided by 12. And that is 5.0583 infinity. I'll put the line on top of the 3 to show infinity. Okay? Or I could write out 3's forever and just sit here and make this video 20 million hours long. Okay? And this is what I mean, like, we got to cut this off at a certain point because how precise our measurements don't allow us to go that many decimal places. So right here, this tells us that our significant digits can only be 2. Okay, that's all I can have is 2 significant digits. I love how I asked it to do red and it still doesn't do red. Nope, still doesn't do red. You see, it's red, right? But it's not red. Okay, so I only have 2 significant digits, so I only can have the 5 would be 1, and the 2 would, and the 0 would be 2. Okay, so if I write it, switch back to black. Okay, so my final answer is going to be 5 points, but right here, this number behind is a 5. So it's 5 or higher, so that becomes 5.1. Okay, so there is my final answer. For division, it is 5.1. Okay, 2 decimal places over here. It must be 2 decimal places over here, and round it off to that second significant figure. Or not decimal, sorry, I said 2 decimal places. 2 significant figures over here, it must be 2 significant figures over here as well. So round to that second significant figure, whatever number is behind it, 5 or higher, make it higher, like we made it a 1. If it was less than 5, we would have kept it 5.0. Okay, let's do one more division. Or was that my last division? Oh, I did one of the multiplication in the wrong place. So I did one multiplication that I was supposed to be doing division. Well, I can do it opposite. So let's do it opposite. It's hard to read between the multiplication and division. Okay, so 40.002 divided by 13.00005. Okay, this is the one I did for multiplication. I was supposed to do it for division. It's okay. It still shows you what you need to do. Okay, so let's put this in the calculator. Divide it like normal. So 40.002 divided by 13.12345 zeros, then 5. And my answer is, I'm going to type it actually to make my life easier, 3.07707574. Make that a little bit different. Okay, so there's the answer in the calculator, but I need to look at how many significant digits I have. So let's look first at 40.02. Okay, the 4 and the 2 are trapping all those zeros in, and I don't need to see anything else. If there's a number that's not 0 on both ends, then all those numbers are trapped and they're all significant. So this one has 5 significant digits or figures. This one's the same thing, right? It's got a 1 on one end and a 5 on the other. So it's trapping all those in. So I've got 1, 2, 3, 4, 5, 6, 7, 8 significant digits or significant figures. I'm used to saying significant digits, but people call them significant figures, significant digits. It doesn't matter which one you call it. Okay, so which one is less is this 5, right? So the 5 has less significant figures, so I need to count 5 significant figures over here. So here's 1, 2, 3, 4, and 5. Okay, so behind that is going to be my line, and I'm ready to write my answer. So I want to keep all those numbers except that last one, the 0, I need to look at the number behind, and that number behind is a 7. So is it 7 or higher? Yes. So it's 7 or higher. So we keep it, and it becomes a 1. Okay. So let me give you an alternate. So this was 7 or higher, so it rounded up that 0 and became a 1. If it was not 7 or higher, so let me do a devil's advocate one. So let's say it was 3.07704 instead. Okay. In that case, okay, we would not round up, we would round it off. And the answer would be 3.0770. You still need that significant digit. This 0 has now become significant because I still need 5 significant figures in this number. So I added this 0 here to show that it's significant, that right here is where the cutoff was. Behind it was rounded down, but we keep that 0 because it's now significant. Remember, you had 5 significant figures here, then you need to have 5 significant figures here. Okay, it has to be the same amount. Okay. All right, so that's it for calculating with significant digits. One last video I'll calculate next with scientific notation.